Then I will talk about the growth rate of GDP. That's what the paper is about. But then let me first say that it's an honor for me to be here. Then I met him long ago, and then we interact every year, at least once a year in Sotomayor. I have to say that I learn a lot from you. Then many of my views in economics are highly influenced by your views. We disagree on others. But,
no, but I was telling my students this week, Omar, when I saw the title, you should have asked me ahead of time. I would have said no, and then you wouldn't have had to write the paper.
Okay, then. Good. That's a very good starting point. And I will try to convince you that it is, right? And then we'll see. Then it means that it will be a lot of fun today. That's a long project in which I was working with Jorge Duran. And then what is the point of the paper? Then we know what GDP is. Of course, we are macroeconomists. We know all that. Basically, GDP, what does measure is expenditure, total expenditure on final goods, and then income. There is the other side of GDP is income, and it does in current currency, maybe dollars, euro, pounds. Then what is real GDP growth is a weighted average of the real growth rate of the different components of final demand. That's the way GDP growth is measured, right? Then, fundamentally, if you go to national accounts, you can show that in the way it's measured today, the growth rate of output is a weighted average of the growth rate of the different items, say in a simple economy, consumption and investment, where the weights are the shares of each component in nominal income, right? Then what is this paper? What we try to provide a rationale for the way national account measure growth. And in order to do that, we do it from the point of view of theory. Then we will do it in a particular framework, say in dynamic general equilibrium theory. And what we will do, we apply what people working on national accounts and the measurement of consumption price indexes, what's called index number theory. And I will be explicit about what it is. Right, but basically, that's what we do. Why? Because the economic theory of index numbers is at the core of GDP and CPI measurement, and because modern macro is dynamic general equilibrium. Right? Then, if we can do some normative statement about what the growth rate of GDP should be, I think this is the framework to do it. Then, how do we do? What we do is we basically show there the division index, and the division index is this object here, sorry. This is a division index, right? It has a division index is an index there you get as the growth rate of an aggregate, whatever the aggregate is the weighted sum of the different components of the aggregate, and the weights are given by the share of each on the total aggregate, right? This is a division index. Then what we show is that the division index is a welfare measure of output growth, and I will be explicit about that. And then in this sense, the implication is the way national accounts measure GDP is welfare-based. And I will try to be precise. What does it mean? It doesn't mean that necessarily we are measuring the growth rate of welfare. What we claim is that the way output growth is measured is based on the welfare of people. Then what is the way we do?
Are you going to address this open economy issue too?
No. That's an issue.
So the value added versus the final.
Yeah, I will not. That's okay. Close economy. That's a close economy. Yeah. Then we know that in a dynamic equilibrium framework, intertemporal preferences are defined on a flow of consumption, right? But national accounts aggregate consumption and investment. Then we need to move from here to something that allows us to do the exercise at this level here. And what we do is we use the Bellman equation, right? Then the Bellman equation allows us to represent intertemporal preferences as a function of current consumption and investment. I will be clear about what I mean by that, right? Then we apply index number theory to this representation of preferences. In particular, we'll use a particular index that is known as the Fisher-Shell index in this literature, and I will be explicit on why we use this index. And then the main proposition comes that the Fisher-Shale index is equal to the division index, and then national accounts is the growth rate of GDP, national accounts are welfare-based measure. Right? This is the basics of, okay, that's say there. Then I will give you an example, and then I will just show you that this is much more general, right? And that our proposition applies to a very, very, very general dynamic general equilibrium economy. We did it in a world with certainty, right? And we should extend it to uncertainty, but we didn't yet. Then think on say, a two-sector AK model. We did this way because then in this economy, there are no state changing over time, but this is just to simplify things, right? It's second order. I could do that in the framework of the Gringo-Herkowitz and Crusell model. The only thing I need is there to think on an economy where consumption and investment are growing at different rates. Otherwise, the aggregation issue is irrelevant. Then in the neoclassical growth model, there is no need of aggregating because consumption and investment are the same good. They both grow at the same rate. Right? Then think on a very simple framework where instantaneous preferences are constant intertemporal elasticity of substitution. And then there are two technologies, one that produces a consumption good and another that produces investment good. Then capital K may be allocated to the production of the investment good, and the technology is linear, the model is AK. But it can also be used, and B is the capital that is used to produce consumption goods. It can be used to produce the consumption goods with decreasing returns. Right? There's Cobb-Douglas in the consumption sector, linear technology in the investment sector. Right? This model is well known. This is in Rebellion 81. Right? Then this is an interesting example. Why? Because it replicates some fact that looks to be important. One is that it replicates a negative trend in the price of investment relative to the price of consumption goods. And in this framework, the saving rate is constant, as it is in the data. And then an important implication of these two facts here is that investment is growing faster than consumption. And this is just an artifact of prices. Then the savings and then investment in nominal terms, the share is constant over time, but the price of investment is going down with respect to consumption, then investment is growing faster. Right? Then the point here is, how should we measure the growth rate of output, given that these two items that we have to aggregate, they grow at different rates. Then the methodology in national accounts, and there's something that you likely all know, is that for a long time they were using last period indexes to measure output growth. Then at some point they changed the way they were measuring the price of investment goods, and they found trends in relative prices. These trends make the last period show up a property that last period has. It is called the substitution bias. And then things were not properly measured. And the national account moved to what today is called the chained quantity indexes. And they use a particular one that's called the Fisher ideal. And the Fisher ideal, what tries is to get something as to be as close as possible to the division index, meaning that the growth rate, I think, is, yeah. The Fisher ideal, the chained Fisher ideal is an index that is very close to the division index. Then you are every year weighting the growth rate of consumption and investment by the shares in national account. That's the way national account move, right? And they did why? Because they observed it there, the relative price of investment was going down. This affected the way they were measuring GDP growth. And then what is rational? The question we try to answer is, what is the rationale for doing it? Yeah? Of course, the rationale behind the way people do is fundamentally a statistical rationale, right? And is there an economical rationale? Then these are properties of the model, but I think I will because that's not the key. Then of course the model has a property that the relative price of investment is going down, yeah? And then the growth rate of consumption and investment is different in this economy. Then this economy is an economy that has the property that at equilibrium, and I will talk about how to measure GDP growth at the equilibrium of this economy, right? I'm not talking in general, I'm talking just you have an economy for which you compute the equilibrium of the economy, consumption and investment don't grow at the same rate. What is the way in this economy of aggregating consumption and investment that is somewhere consistent with the preference of people? This is the exercise, right? Then our aim is to build an index that reflects changes in welfare, but using observables, and that's what national account does, right? And normally in national account you face the problem that you cannot observe preferences of people. You don't observe future consumption that you will observe tomorrow, but not today, right? What you observe today, that's another. What you observe today is current consumption, current investment, and you may have the history of both, right? The other important thing here is, and this has to do with the way things are measured, is that we know that preferences are not univocally represented by a welfare function. There are a lot of representation of the same welfare function that also represent the same preferences. And the growth rate of a particular representation of preferences of a particular utility function is meaningless, right? Then the point is that what we will do in this exercise is for this economy, then we'll try to measure welfare changes using current consumption and current investment, as NIPA does. Then, remind this is the representation of preferences of households. They depend on the flow of consumption. But if you write the Bellman equation, this is continuous time, right? Then in continuous time, this is the representation of the Bellman equation. Then rho, the value of asset of this economy, the discounted flow of utility of individuals, is equal to the max of current consumption plus the value of investment, where X is net investment, right? And then this is just the marginal value of capital, right? That's standard theory. Yeah? Then what we do is we will apply index number theory to this object here. Yeah? Say, we are not computing again equilibrium. Then equilibrium is what it is, right? And you know the economy, you are good macroeconomy, you know how to compute the equilibrium of this economy. What we are trying to figure out is a way of measuring from the observables of this economy, measure changes in welfare, and try to see if this way of measuring some way give us information about, I don't know, GDP. Yeah? Here we know that something I'm not being explicit, but I should, is that in fact all the theory is about net domestic product. It's not about gross domestic product, because the key thing here is in terms of welfare, what matters is net investment, not gross investment, right? But that would say is somewhere second order. Yeah? Then I'm back to, then this is the standard representation of preferences. We don't observe consumption at time t, but we observe consumption and investment at time t, and we will use the Bellman equation in order to use index number theory on this representation of preferences, right? Then we'll just apply index number theory to this object here. Then the right-hand side represents preferences in the consumption investment space. One thing that I will use later, and then I think it's a way, because then I will try to interpret what we have, the result we get. Think that what the Bellman equation tells you is that the return to assets, the return to the asset of the economy, is equal to the utility, the current utility of consumption, plus the value of investment, right? Then you are using your asset in order to produce consumption and investment goods, and then the return to your asset is just the GDP, right? NDP. Yeah? Then now I will apply index number theory to this object. Then now I'm moving from the, I think I have a, oh no, it's not there. No, okay, it doesn't matter. Then what I will do now is to take the perspective of an individual in this economy, their, say, the representative agent, that has to decide how much to consume and how much to invest, given this problem here, that is to maximize the current utility subject to the budget constraint. And the budget constraint has an exogenous element for the individual, the income of the individual, and the price. Here, everything is measured in terms of the consumption good. Then the price is 1. That's our numeraire. That's irrelevant. I could choose any other numeraire, but I'm taking it. And then Q is the relative price of investment, right? One thing that is important for the following is that this utility function, this representation of preferences, is time dependent. In this case, it's clear why, because when capital evolves, this economic capital will be growing, then the marginal value of capital will be changing over time, right? Then V prime of k is not necessarily constant. Yeah? Then the representation will be changing over time. Okay, then now is basic micro. Yeah, that's a micro 1.
But can you advance something?
Yeah, tell me.
Before, you said your measure would not depend on utility function and on future plans, right?
Yeah,
But you're going to base
I will
the
show you.
measure on this function.
right, but
But V is
I agree.
utility. So can you advance something? Or how
Yeah,
are you gonna get to the
because
future
it's here.
V
There's
depends on
two
V?
slides, and you will
Okay,
be there.
I'm waiting.
Right, then now this is basic micro, right? Then we define the indirect utility function by solving the maximization problem, and then putting here the solution, and then utility at the max will be a function of income and prices.
You know, V,
Right.
it's
Of course, but I know V because I know the economy. Right? For my economy, I know. I'm claiming that if I know an economy, and I will try to be as much general as possible I can, then I can apply to this economy index number theory and show that
but then this is like knowing future utility and future plans.
right? But I will not use this information because people in national account don't use because they don't observe it. You say in this economy, yeah, I can compute it. I would be able to use it. Yeah, that's fine. That's fine. I'm just think it as a way of giving a rationale to national accounts. Nothing else.
That's okay.
You can do other things. Of course, you can do other things. I don't claim that you cannot.
The representative age and assumption is crucial, no?
No, I will be back at the end. Unfortunately, I don't have precise slides, but in this framework, we can prove that even if agents have different preferences and different income, then you can define an aggregate as national account does that give you the division index as a welfare measure. We can do that. It's in the paper. We did it some weeks ago, but then it doesn't depend on the. Of course, it depends on the economy. It depends on, say, if I just aggregate consumption and investment, it depends that there are no other goods in the economy, right? It depends on life expectancy plays no role, and health is irrelevant. You see, I fully agree. It depends on the relevant thing being consumption and investment, yeah. However, I don't know, we think that may be a way perhaps in thinking on how to add other components to national accounts. Yeah. I will also talk about some limitations of because it's to give you right? We don't know how to deal with externality here. We don't know. And perhaps this is a bad measure. Then perhaps we don't get the division index if there were externalities in the economy. And we know there are. Yeah, it's a pity. Yeah, right. Yeah. That's fair. Okay, then there is the indirect utility function. Then there is the expenditure function. You minimize the cost of just producing some level of utility U. And then we'll use these two objects to define what in the literature of index number theory is called an hypothetical level of income, right? And then you know income at period t, right? You will move ahead, say this continuous time, to some period t plus h. We'll observe income at t plus h, right? But prices are changing. You will have a price at t and a price at t plus h. And you would like to find a way of measuring changes in people's welfare that some way take into account the fact that there is inflation and eliminates inflation from the picture, right? Then what these people do is they create what they call an hypothetical income tomorrow. And that will be what? I think this is a picture. Sorry. This is basically the exercise. And then these are two indifference curves corresponding to this individual, to the representative individual. This is the budget constraint time t, is this consumption and investment. Then things are measured in consumption good, and MT is the intersection point here, right? Then MT plus h is this number here. This is the budget constraint tomorrow. right? And this is what you do today. And I will be more clear later about, but say this is what you would do tomorrow, right? And then you try to find out how do you get the same level of utility with the tomorrow prices. And that will be the level, this is, no, today's T, let's say T plus H prices. Oh, sorry, yeah, today. Yeah, right, sorry. With today prices. Yeah. Right, and that gives you this hypothetical level of income. That's basic micro. The only particular thing here is there, you know that this representation of preference WT is changing over time because capital is changing, then the value of investment is changing, right? Then you have to take a stand. You cannot, if you cannot compare using in different curves coming from different different maps, right? Then what Fisher-Shell does is they propose that you take current preferences, time t preferences, right? Then that's the reason why E and U are preference corresponding to period t, and then you're in different curve, you evaluate utility corresponding to future income and prices, and then the expenditure is to give you how much you will get if prices were current prices, right? This is the way things are measured. Yeah? Okay, then this is basically the exercise. Then what is a Fisher-Shell index? That you just take the time change of it. Yeah? And what is the main proposition of the paper is that we prove that the Fisher-Shell index when to this economy is equal to the division index. Right? Here, of course, it continuous time, then things are helping us because then when you are in discrete time, you don't know exactly what the shares are at the period because it's a combination of whatever is ERT and ERT minus 1 or ERT plus 1, depending on the way you are measuring. Here not, here you get exactly the shares, right? Then the paper, and this is, say, half a page proof, a page proof. That's very simple, right? Then, and this is the point of the paper. The point of the paper is that we start from a general equilibrium, dynamic general equilibrium model. We use the Bellman equation to represent preference in terms of current consumption, current investment. We apply index number 30 to this economy, and we prove that the index that we build is equal to the division index. That's what national account does. Then what national account does is, the way national account measures the growth rate of NDP is welfare based. This is the paper, right? Then, now let me try to interpret the result. And what do we have? Yeah. Remember that B measures the value of the representative agent assets. Yeah. Then it's the discounted flow of consumption. And that this V is one among many possible utility representations. Then the growth rate of V has no meaning. Yeah. What index number theory does is it adopt a norm. It's a way of saying, I have all these possible representation, we'll pick one. And the growth rate of welfare will be the growth rate of this particular representation. How they do it? Basically what they do is they adopt current income as a norm. You see, it's as if you were saying, okay, my utility at time t, as represented by this object here, is just current income. It's M. Right? And then I will create an hypothetical M tomorrow when I take into account changes in prices. I will compare it to current income. Yeah? Then this is the norm you adopt in order to measure changes in welfare, knowing that, of course, Vk is arbitrary. Right? It's as if they were picking a particular transformation of V that is the one that is consistent with the way they are measuring. That is the, right? It's some way very tricky. The point of our paper is not to say that when GDP grows at 3% is because welfare is growing at 3%. What we want to say is that we can interpret this 3% as something that comes from preferences of individuals, right? Of course, we can change the norm and we'll get a different number.
So
and I will,
representation that is consistent with 3%, that's what
right, this, yeah, that's what I want to say. And I will give you an example. that some way is very paradoxical because it contradicts my statement. I have two economies where welfare will be exactly the same, people will be the same preferences, consuming exactly the same thing, and apply it and I get different numbers, right? But in any case, this number is welfare based. That's the statement of the paper. Right? That we want to say that there is a transformation of any representation of preferences, any value function that grows at the rate given by the Fisher-Shell index. Yeah? And you see, one important thing is that the Fisher-Shell index does not depend on preferences. It depends on equilibrium. Then if I give you the equilibrium of the economy, even if you don't know what preferences are, you can compute the growth rate and claim that this is welfare based. Right? This is the. If I am in a framework where intertemporal preferences are additively separable, then I will always get rho v at the left-hand side. Then my measure given that my return is constant, the growth rate of my income will be equal to the growth rate of v. Then it's even more general what I'm saying. You see? Then I've just the number I get has to do directly with v. It's not true in the general case, right? Yeah? Is that okay? Then does investment matter? And this is some way was a debate in this literature of embodied technical progress at the beginning, that people stopped talking about that. But should we measure welfare through the growth rate of consumption or not? Is that enough, right? Say the application of the index number theory to our problem tells you that's not true. And should the consumption growth rate summarize what is relevant? And the answer is no. Right? And I give you an example in which it clearly is not the case. Right? The second thing is what matters is not gross but net investment. That was matter. That's a statement that was made in the 70s by Weissman in a close but different framework. Okay, that I already said many times. Then what's the general framework? Then we can prove exactly the same. We can apply exactly the same index to a much more general economy. Think on an economy where preferences are recursive and the production possibility frontier is as general as you want. Then say I define preferences in a recursive way. Yeah? And I define my feasibility set in a very general way where theta are, say, technological parameters that are evolving over time. Right? Then when I maximize say I can use a Bellman equation here. There is a Bellman equation representation of the problem where you will get again this function Wt that depends on C and X. Then given that our proof didn't depend on the particular functional form of W, you will get it again. Right? And you can prove in a very general framework. Of course, the framework needs to be an intertemporal dynamic equilibrium model, and it has to be a framework where there is only two goods, consumption and investment. Right? But then it's very general. Then the two-sector EK model is just a particular case. Then let me now talk about two examples that I think clarify the main statement. Then consider an economy of embodied technical progress. Yeah? I think this is well, sorry, I will go slowly. Then suppose that there is some period t and an expected acceleration of the rate of embodied technical progress. Right? And then assume that consumers find it optimal to initially reduce consumption. It could be. They initially reduce consumption in order to invest a lot and then profit from the new rate of embodied technical progress, and then the economy will be in a new growth path later. Right? It's clear that welfare will increase because this economy is an efficient economy, and what we are doing is we are improving the environment of the economy. Welfare has to go up. There is no doubt, right? However, consumption at T is going down. It's clearly the growth rate of consumption does not measure welfare. Then you have to, and this is the role of the division index, you have to take into account that what you are doing is you are investing in order to postpone consumption. And what investment represent the value of investment today. It's just the discounted value of the future consumption you will get from it. Then you have to add it up to your measure of welfare, right? Okay, and in this case, in top of that is very, very obvious, because then if technical progress is embodied, you need to invest. Otherwise, you will never profit from it. You have to invest today in order to profit from technical progress, right? Then faster growing investment today is our best proxy for the preference for faster consumption growth tomorrow. We are doing it in order to get a larger growth rate of economy. This will be the representation of the economy. Right? Then an economy of this type, clearly consumption is not a good, the growth rate of consumption is not a good measure of welfare of people. The division index represents that. But let me now give you a paradoxical example. That's the example I referred before.
But Omar, let me
Yeah.
ask you about, you're looking at an aggregate economy.
Right, yeah.
The technological progress or whatever is driving this high investment is maybe at several sectors. So when you take everything into account at a certain level,
Right.
you may be balancing out some sectors over the others. So then we still
Right.
see changes in consumption
Uh,
over time. You see, so over time you will see some sectors having larger investment and postponing consumption.
Right,
and other
right, yeah.
sectors not. So
Then if the level,
that
we,
change then if you
yeah.
reduce
We didn't for the moment, but we strongly believe that it can be easy to do, is that if we have an economy with many different type of consumption goods, they may be non-durable, durable, different type of investment goods, then if you apply exactly this, you will get again the division index. You see, you will be aggregating first the non-durable consumption goods on an index of non-durable consumption, then durable consumption and index of durable, then investment in an index of investment goods, and then you aggregate everything on GDP using the same methodology, that's the methodology used by NIPA. Now, then, I have strong belief that this aggregating is not a problem. Of course, the economy has the properties, and we are working in economies that are efficient. Yeah? Then let me just give you an example that is paradoxical. And the example is very good because think that the value function contains information not only about the preferences of people, but also about technology, because it contains information about the equilibrium of the economy, right? Then not only preferences, but technology matters. Then assume now that there is the two-sector AK economy that I just described summarily at the beginning. But what's important is think that in this economy you have investment and consumption growing at different rates. And suppose that parameters are such there that investment grows at 6%, consumption at 2%, the investment share is 20%. Then you compute the division index. Then output will be growing at 2.8%, right? That's your measure. That's what our theory say. That's a correct way of measuring things. It's welfare based. Yeah? Now suppose that there is another economy. That's a pure endowment economy. Yeah? Exactly the same preferences. But of course there is no production because it's endowment, right? And then God is giving us as mana exactly the consumption path of this economy here. The same, exactly the same. Then being in these two economies, you will be indifferent, right? Because then you will get exactly the same thing in terms of utility. Yeah? However, if you apply the division index to the second economy, the only thing you are, say, producing is the consumption good. This economy is growing at 2%, right? Then these two measures are welfare-based. We are applying the division index. I can go back and do all the exercise, and I will show you that the Fisher-Shell index in this economy will be 2.8%. In this economy, will be 2%. In both cases, equal to the division index. But these economies are not growing at the same rate, right? Why? Because income is defined in a different way. We don't have exactly the same definition of income because here we need to produce investment goods in order to consume tomorrow. And we will consume more because there is technical progress that requires investment. And here not. It's just God giving me mana every period. Right?
How about the following? Imagine an economy that just went through a very destructive war, tsunami, and it lost a lot of capital.
That's a very good point.
And,
Yeah.
After is over, their growth is likely to be very high,
All right.
but their welfare is not.
I totally agree. I totally. What is going on in this economy is that there is a destruction of capital. Your initial value goes down, black, right? You don't register it.
Right.
It's not in national account. However, the growth rate of GDP the first year will tell you how much your welfare, in this measure this way, improved with respect to the very bad situation you were at the beginning.
Sure.
Right? This is our statement. You see,
But if I compare two economies, one growing at 8%, Germany in the late 40s, 8% or 6%, and Japan or some other economy later on working on, they were not in the same situation.
I fully agree. And the growth rate of GDP does not measure it. I agree.
So
I agree.
what's
Then
going wrong? Why
no,
doesn't
nothing
your
is going
formula-
wrong. Nothing is
why
going wrong.
doesn't your
No.
formula apply?
The growth rate of GDP is telling you, in a particular way, how much your welfare went up from what it was
Yes.
during this year. That's all.
So
That's
what
all.
you
Then,
say
if you
that-
come, you bomb an economy, that's not in GDP. Then,
what you're saying is a good measure of the growth in welfare. It's
Gi-
not a good measure of absolute growth. Okay.
yeah. So, yeah.
Okay.
Because in top of that, you're measuring the returns. Think that GDP is a return on your welfare. It's not your welfare, right? Then, right?
Yeah.
Okay, that's that I think I already say. Then now, then some of the things we think they are easy to do, then the possible extensions, some we already did, even if they are here. Then that I already say in the answer to Teresa. No, there is only one non-durable consumption good, easy to extend to a basket of non-durable goods and services. Only one investment good, I think it's easy to extend to different investment and durable consumption goods. Then here we are in an economy that's efficient, where prices reflect marginal productivities. We think we didn't yet, but I think it's quite easy to extend it to an economy where there are some price distortions. Why? Because if you reduce the price distortion, your output will go up and it will reflect in your real income, and this is reflected here. Then it seems that we didn't, but it seems that this is easily to be done here. And then that we did, and I was surprised because I didn't expect it. Then if you then the exercise we did is for a representative household. Suppose that households are different, that have different utility function. What is key here is that the function omega. Remember, we are in the standard dynamic general equilibrium with additive preferences. Then you get the value of capital. Right? Then investment always.
Not this one.
Then investment always come linearly. The representation is quasi-linear. Right? I think it would be enough. Then the representation is quasi-linear. Then under quasi-linearity of preferences, because what we did here, what we did is we computed a level of hypothetical income for each individual, and we did a national account. We computed total income and total hypothetical income, right? And then we applied the Fisher-Shell index, and we got the division index. And why is it the case? It's because of this property. Then, given that this utility is quasi-linear, then when you write the sum of this hypothetical income, you get income linearly, right? Because of the quasi-linearity, right? And given that you get it linear in your representation of preferences, then you get the Fisher-Shell index. That's and some way, if I were to interpret the result, the idea is the following: is there the Fisher-Shell index is a division index, and the NIPA is measuring the growth rate in NIPA is a welfare measure, as if your welfare aggregate measure were utilitarian. But that's what we do in national account. We add up income, right? Adapting income some way come from the idea that it doesn't matter if we are different or who, then we just think on people as adding utility. That's what comes directly from applying the Fisher-Shale Index to an economy with heterogeneous agents, right?
But this must be, I mean, if people were borrowing constraints, I don't think this would work.
That I don't know. That I don't know.
Then,
That I don't know.
then these aggregations
That I don't know.
because you lost the.
But if we were in an economy of misallocation, where misallocation is because prices are distorted, you can apply it. I'm almost sure. I didn't, but I'm sure. But no, this type of thing I don't know. That I don't know. I don't know how to deal. That I should add. You see, because then I know that externalities I don't know yet how to deal with. Inequalities I don't know. You see, you need to be an interior solution to apply the things. Then the proof depends strongly on being an interior solution. Yeah. And that's all. I think. Yeah.
How do we think of this utility of labor? Because that's another component of welfare, no? And here, it's not really included in the analysis, no? Maybe that's from the income side of GDP.
Let me see. Because, I would say that it should. They should not be, because you can. Leisure is also a type of good, and the only point is that you are not measuring leisure in national accounts. Right? But then the theory will tell you how to do it. Right? Likely the standard way. If we were able just to price leisure and then to add it to national accounts, then we will have a sector producing leisure, and then. But we didn't it yet. No. I would say that adding to the framework anything that is on the same nature of a consumption or an investment good should work. The problem in national accounts is there are things that you cannot measure or difficult to measure, no, as leisure. Okay, then I put conclusion, but team will not agree on that. This is just a summary. Okay, thank you.